Hello and welcome, people of the internet and programming enthusiasts. In this video, we will be discussing Python imports. You've used import in Python 1,000 times, but do you know what it actually does? It would seem like import just brings in some code from somewhere else, but Python is doing a lot more than just reading in code from another file. When Python encounters an import statement, a series of steps occur. First, Python checks if the module is already loaded by checking an internal dictionary called sys.modules. Sys.modules is a cache, a dictionary that maps module names as strings to module objects. Think of it as a registry of everything Python has ever imported. If we check if an item is imported, import some kind of module, and then check if the module is imported again, we can see that the list of imported modules updates with the module we just imported. Let's create a module of our own to import. We will also add some top-level code that will be executed immediately. In this case, a print statement. If we try to import this module multiple times, it is only imported once because a reference to the module already exists in sys.modules. If the module were imported multiple times, we would see multiple print statements because of the top-level code being executed. This leads us to the next step in the import process. Python starts looking for the imported module using something known as the module search path. The module search path is a list of directories stored in sys.path. Since Python does not magically know where your module would be, it searches through this list of directories. Built-in modules are found instantly since they are compiled into the Python binary. Other directories like the current working directory, the Python path, standard library paths, and the path to third-party packages are then searched. We can see where a module was loaded from by using the dunderfile attribute of a module. This is a good way of verifying which version of module you are importing if you have naming conflicts. Once Python finds a matching module, it stops and prepares to load it. If Python cannot find the imported module in any of these paths, we get a module not found exception. If we have a custom module somewhere, we can add the path to that module by appending to sys.path, and Python will be able to find the module. Once Python finds the module, the next step is to make sure it's in a format the interpreter can efficiently run. This is where bytecode compilation comes in. When running a Python script from a file, you may have noticed a dunder py cache directory being created. This directory contains the low-level representation of the code that can be executed more efficiently. When the PYC file is run by the Python interpreter, Python executes the module only once and does not run anything in the module unless it is explicitly called. And finally, Python then binds the module's namespace to the name you used. By default, the name of the module is bound to a variable with the same name as the module itself, but you can customize this using the as keyword. Let's add a quick function to our sample module file to demonstrate this. Now we are importing just the foo function from the module and assigning it the name bar in the current namespace. This can make long or awkward names easier to work with or help avoid naming conflicts. Just keep in mind, when you use from import, you are pulling that specific item directly into your namespace, so you lose the module context. If two modules have a function with the same name, importing both this way can create conflicts. Let's try another example and create a file called utils. We can add a simple function in here just for demonstration purposes. Now we can import the utils module, call the greet function, and display the output. When we run it, Python looks for the utils module in sys.path, compiles it to a PYC file, executes it, adds it to the sys modules dictionary, and binds utils to the current namespace. Now let's talk about packages. In Python, a package is just a directory that contains a special file called dunder_init.py. This file tells Python, hey, this folder should be treated as a package. It's a way to organize related modules under a common namespace. If we create a directory called utils and move our utils.py file into it, we can turn it into a package by adding a dunder_init file. Let's add a print statement so we know the utils package has been initialized. We can now import our utils module from the utils directory and call the greeting function. If we output the greeting, we can see the message we added to our dunder_init file, as well as the greeting from calling the function in the utils file. Dunder_init is still good practice and useful for package initialization. Here is something interesting you may not have known. If you add a zip file to your sys.path, you can import modules inside the zip file like a regular module. Let's create a zip file, write to a file inside that zip file by adding another simple greeting function, add it to our sys.path, and then import the module. This zip file acts as a mini package, and since there is valid Python code to be executed, it is compiled to bytecode. So to recap, here's what happens when you import Python checks sys.modules, searches sys.path, compiles to bytecode if needed, executes top-level code, and finally binds the module to a name. That's all there is to it. It is simply a well-orchestrated process that involves searching, compiling, executing, and caching. And now you know exactly how it works. If you enjoyed the video, please remember to like and subscribe. As usual, I will leave a GitHub link in the description if you want to have a look at the code yourself. Until next time, take care and goodbye.